up until this point, we've been given the equation of a line and then asked to find properties about it, like what are the x and y intercepts, how do you graph the line, all different questions like that. Now we're going to kind of do it a little bit backwards. I'm going to give you some information about the line, and I'm going to say, okay, what's the equation of that line? So kind of a little bit backwards from what we've looked at. To do this, we're going to need a formula. Like, this is called the point slope formula, and you're going to use this equation anytime you're told to write the equation of the line. So use this formula anytime you are told to write the equation of a line. Now, like any formula, you need to have some information to plug into this formula. So to use this formula, you need a point on the line and the slope of the line. All right, so to use this formula, you need two pieces of information. You need a point on the line. Now, generically speaking, we're going to call this point x1, y1, and we're going to need the slope, which is m. So we're going to start with this formula, and once we have a point, we're going to replace the x1, y1 with the point, and once we have the slope, we're going to replace the slope in for m. Now, one small little subtle thing right here that students get confused with. What's the difference between a form and a formula? Because we've seen forms this chapter and formulas. Well, a form, we've seen two forms so far. Ax plus by equals c and y equals mx plus b. This was standard form and slope-intercept form. Think about a form as a way to express your answer. So if you're told to write the equation of a line, you're either going to give your answer in one of these two forms. A formula is something you plug values into to get to an answer. So we actually have two formulas this chapter also. We have our slope formula that tells us x2 minus x1, that tells us the slope of the line if we plug in 2 points, right? We plug in 2 points and this tells us what the slope is. Now we also have, we now have our new formula, our point slope formula, which means we plug in a point in the slope and it tells us the equation of the line. Now, the good news for this formula, at least at this level, we're going to almost always be given a point. What we may not be given is the slope, so we may have to fight for the slope, either using our slope formula or using our slope-intercept form to find the equation, or find the slope of another line. So the slope may require us to do some side work. All right, let's get rid of all this and start over. So we're going to take a look at a couple of examples how to do this, and for each one of these, the directions are going to start, find the equation of the line. All right, let's say that passes through 1, -3, and -5, 2. Okay, so find the equation of the line that passes through these 2 points. All right, so anytime you're told to write the equation of the line, the very first thing you need to do is write down your formula. Now tell yourself, say, okay, what do I need to use this formula? Well, I need a point on the line and the slope of the line. The good news in this case, we have plenty of points, right? We have 2 of them. We can use either one. What we don't have is we don't have the slope. So without having the slope, we know that we're gonna have to do some side work here because we don't have our slope. Well, we do have 2 points, and we know to find the slope given 2 points, we have a formula for that. Y2 minus y1 all over x2 minus x1. Remember how we kind of did this the first time? We want to label these to make it easier to do. X2, y2. And then just plug it into our formula here. So we said y2 was 2 minus negative 3 all over x2 is negative 5 minus 1. All right, a little bit of algebra, that's 2 plus 3 over negative 6, or negative 5/6. All right, now we have a slope, and we have a point. We can use either one of these 2 points. Generally, I say pick the one that you think's the nicest. I'm going to just use the first point because, well, it's the first point. I get y minus negative 3 is equal to negative 5/6 x minus 1. So I plug my slope in where m is, the negative 5/6, and I plug my point in. You could use either one. I plug my point in where the x1, y1 was. Now at this stage, we're not quite done yet. We may still have a little bit of work left to do. Here we're going to be told what form to put our answer into, because remember, a form is a way to express our answer, and we have 2 different forms. Either we have standard form or slope-intercept form. So the book's going to tell you which way to leave your answer. Now, in terms of life, if nobody tells you what form to put your answer in, put it in the slope-intercept form. 2 reasons. One, it's easier to do of the 2. It's much easier. And second, it's a lot more useful. It's easier to graph the line, and you can just look at it and see the slope and the y-intercept. So here we weren't told what form to put our answer in, so let's go ahead and put it in the slope-intercept form. To do that, well, the first thing we need to do is clear our grouping symbols. Plus 3 is equal to negative 5/6 x plus 5/6. Right, all we did over here was, of course, distribute. Now we have to subtract 3 from both sides. So we get y is equal to negative 5/6 x. Now here, if you're not good at arithmetic, you need to go over to the side and scribble this out. That's 5/6 minus 3. You need a common denominator, which is, well, 6. So this is 5/6 minus 18/6. Well, those things are 6, so we're going to have 6 here. 5 minus 18 is 13. Of course, it is negative. So there we go. There's the equation of the line that passes through these 2 points, and in this case we put this into slope-intercept form. All right, let's try another one here. Let's make it a little bit easier. Let's say it's still the same directions. Find the equation of the line that passes through 2, 3 and has a slope of 4/5. Okay, so find the slope of or find the equation of the line that passes through the point 2, 3 and has a slope of 4/5. Now, the key of this one is it says answer in standard form, so we know how we have to express our final result. So just like before, the very first thing we want to do is we know we're writing the equation of the line, so write down your formula every single time. Then you say to yourself, okay, what do I need to use this formula? Well, I know I need a point on the line, that's the x1, y1, and the slope of the line. The good news for us on this one is that's exactly what we were given. So we actually don't have to do any side work for this. So we get y minus 3 is equal to 4/5 x minus 2. Okay, so there we go. Now all we got to do is rearrange this until this is in standard form. Now, a few things about standard form. Remember, this is what standard form looks like. Ax plus by equals c. It has all the x's and y's on one side and all the numbers on the other side. Now, that's all I've set up to this point. A lot of textbooks will add a few more conditions on what A, B, and C will be. Most textbooks say A, B, and C can't be fractions or decimals, and a few textbooks out there actually say that X has to be positive as well. I don't necessarily agree with that last one. All I care about is, let's go ahead and make sure that these are are integers, right? Not fractions and decimals. So again, we're just gonna follow our steps for solving a linear equation. So first step is clear grouping symbols. That's gonna be 4/5 x minus 8/5. Now, since I just said that A, B, and C can't be fractions or decimals, step 2 for solving linear equations says clear fractions or decimals. Let's go ahead and do that. Our least common denominator here is 5, so I'm going to multiply every term by 5. 5 times 4/5 x minus 5 times 8/5. Okay, so on this side we get 5y minus 15. On this side, 5 goes into 5 once, so that's just 4x. 5 goes into 5 once, so that is just 8. All right, now remember what our goal is, to get all the x's and y's on one side and all the numbers on the other side. So let me go ahead and move the x's this way. Doesn't matter which side you move them to, by the way. So once I do that, I get negative 4x plus 5y minus 15 is equal to negative 8. Then move everything else to the other side. So we got the stuff we want on one side, move everything we don't want to the other side. So we're going to add 15 to both sides. So I get negative 4x plus 5y is equal to 7. Okay, so there's the equation of the line that goes through the point 2, 3 and has a slope of 4/5. Now, something you will or might see in a book, remember I said some textbooks want the lead coefficient or the number in front of the x to be positive. So if you were to take this equation and you were to divide through by -1, divide everything by -1, you would end up with 4x minus 5y is equal to -7. If you ended up with that, that's also a correct answer. And to be honest, I don't care which one of these that you happen to give me, but you have to give me one or the other. All right, let's take a look at one more type here. One more thing we might run into. Let's see. Find the equation of the line. Same start for each one of these questions. Let's say that passes through -2, 4 and is perpendicular to the line 3x plus 2y is equal to 5. Okay, so find the equation of the line that passes through the point, what did I say, -2, 4, and is perpendicular to the line 3x plus 2y is equal to 5. So again, since the direction said write the equation of the line, the very first thing you're going to do is write down your formula. So to use this formula, we need a point on the line. Hey, we got one of those. We also need the slope of the line. We don't have that. So since we don't have the slope, we know we're going to have to do some side work. So let's give ourselves some room and come over here and do some side work. Now, what's this side work going to involve? Well, the only information I haven't used is this other line, and I know I want to be perpendicular. So I know my side works, was it 3x plus 2y is equal to 5. It's going to deal with that line. Well, we got to ask ourselves, what do we know about perpendicular lines and their slopes? Well, we know that perpendicular lines have negative reciprocal slopes. So if I could figure out what the slope of this line is, then I could figure out what slope I'd want to use. Well, we saw if we take a line and put it into slope-intercept form, we can just look at it and see what the slope is. So let's go ahead and put this into slope-intercept form. And very quick and easy to do. So I get 2y is equal to -3x plus 5. Dividing by 2, dividing by 2, so we get y is equal to -3/2 x plus 5/2. So just by looking at this, I can see the slope of this line is 3/2. All right, so from here, two different things can basically happen. Remember, we want to be perpendicular, so we don't want this slope, we want the perpendicular slope. Now the notation that we've seen in the past is the symbol for perpendicular as a subscript, so this would be the perpendicular slope. Remember how we do that? We flip it over and change the sign. Now this isn't part of this question, but you can kind of see how this would work. If it had been, instead of the word perpendicular, if it had been parallel, The only way that that changes this entire problem would be at this step right here. We would take the parallel slope, which of course is the exact same thing. So the only difference between using the word parallel or perpendicular occurs at this step, and that's when we choose what slope we want to use, right? If we want to be perpendicular, we want the negative reciprocal slope. Flip it over, change the sign. We want to be parallel, we would use the same slope. All right, so now that we have our slope, and remember we're using this one, we're perpendicular this time, and our point. So let's plug this in. So I get y minus 4 is equal to 2/3 x minus negative 2. All right, now notice this problem here, unlike the last one we did, didn't tell us what form to put our answer in. So I highly suggest using slope-intercept form. So to do that, we need to clear our grouping symbols. This is going to take a couple of steps this time because we have this minus and negative, so that becomes x plus 2. Now go ahead and distribute, so we get y plus 4 is equal to 2/3 x plus 4/3. Last step, subtract 4 from both sides, so we get y is equal to, let's go and move it up here, 2/3 x plus minus, let's see, let's go ahead and do this over here again. If you're struggling with the arithmetic, when you add or subtract fractions, you need a common denominator, which in this case is 3. So of course that's going to be 4/3 minus 12/3. So our answer has to be in thirds. 4 minus 12 would be negative 8. So there we go. There's the equation on the line that passes through the point negative 2, 4, and is perpendicular to this line that it was given. Again, if you're given the word parallel, the only difference occurs at this step right here when you're comparing the slope to the other line. You're either going to take the perpendicular slope and plug it into your formula, or the parallel slope, plug it into your formula. And then from that stage, put it into whatever form the author says. Either you're going to be putting your answer into slope-intercept form or into standard form.